Metacentre. When a solid body floating in a fluid is tilted from its equilibrium position, then the stability of its equilibrium depends upon the location of its metacentre. To understand this, let us recall that a solid body floats in a fluid. If the mass density of a body is less than that of fluid, as in case of wood, plastic, ice cube, etc., and if the weight of fluid displaced by the immersed body is equal to the weight of the body, as in case of boat, ship, etc., when a body, say a ship, floats in water, it is acted upon by two forces. A vertical downward force of gravity, which is equivalent to the weight of the body, W, acting at the center of gravity, G, and an upward vertical buoyancy force, FB, which is equal to the weight of the water displaced by the immersed body, which passes through the centroid of the displaced volume of water, that is, the center of buoyancy. Now, for a floating body to be in equilibrium, the buoyancy force should be equal to the weight of the body. Also, the center of gravity and the center of buoyancy should lie on the same vertical line, called the center line, BG. Now, if a body undergoes an angular displacement, say in the rightward direction, then we see that the volume displaced is larger in the right side. Thus, the center of buoyancy shifts towards the right from B to B', and a couple is formed which tries to rotate the body. Here, the point of intersection of the vertical line through the new center of buoyancy B' and the center line BG is termed as the metacentre of the body, and the distance by which the metacentre lies above the center of gravity of a floating body is known as the metacentric height, GM, which is given by. Depending upon the location of the metacentre, a floating body possesses three types of equilibrium. They are stable, unstable, and neutral equilibrium. When M is above G, then in this case, a restoring couple is formed by the buoyancy force and the weight of the body, which tends to turn the body to its original position. Thus, the body is said to be in stable equilibrium. Now, when M is below G, then in this case, an overturning couple is formed by the buoyancy force and the weight of the body, which tends to sink the body from its original position. Thus, the body is said to be in unstable equilibrium. And when M coincides with G, then in this case, the line of action of buoyancy force and the weight of the body are collinear and passes through the same point. Due to this, the body neither returns to its original position nor increases its displacement further. Thus, the body is said to be in neutral equilibrium.